Hello everyone. How are you? I'm your friend, your mentor, your physics faculty for today, Saurabh. And welcome to this yet another episode of Exemplars, right? Exemplar Sprint as you know it. Now, for quite some time you have been asking us that let's start these live sessions for class 9th, and you know what? We heard you. We are here for you, right? So this is the place where we'll deal with class 9 topics. And today we'll be dealing with motion, all right? So, I welcome everyone. Welcome Papiya, Shaurya, Harinshri, Miss 14. Hey. All right. Krishna, hello. Deepak. Rutraj. Nice. Hello, Shinja. So, are you guys excited for these class 9th topics? The one thing that is different here is we have very short answer types, we have long answer types, we have short answer types, right? We have MCQs also. We have to cover a lot of territory. And that's why we are going to have these sessions. We are going to have these regular sessions. Now you can believe it, right? We are going to have these regular sessions and we are going to have a nice sprint of exemplars, of good questions from exemplars, all right? Yeah, Papi, I know you. Yes. Harinishri says, please raise your volume. Am I not very clearly audible to all of you? Let's do this one more time. Am I clearly audible and visible to you? Harini says, my volume is low, right? Is it for everyone? Can you guys just confirm it to me? Hello, Anushka. Yes, class 9th. Yay, class 9th. All right, article says, I'm clear, audible, nice. All right. It means technically we are all good and sound, all right? So Harini, if you are still facing problems with the volume, just check is the net connectivity all right? Okay, all right guys, come on. Shall we start now? Tell me. This chapter of motion, what do you think? Is it easy? Is it difficult? Because from my experience, I feel there is one topic a lot of students are scared of. Can you tell me what is that? Come on. Let's interact. Come on. All right, Harni. Now, okay. Very good. So what do you think? What is the most difficult topic you feel in motion? Easy peasy. Yes, Chitra, your chat is visible. Srinija, class 8th will also start. As I promised in class 10th sessions that we'll start with 9th. We are started with 9th. I'm promising you we'll start with 8th also. The channel's name is 8th, 9th, 10th, which means for sure we are going to conduct classes for 8th also, alright? So don't you worry. You'll get the notification very soon. Alright? Equations of motion, you say. Alright? Laws of motion. It will come. Don't worry. Hello, Chitra. Numericals are hard, Kevin says. Numericals are hard. I agree with you, but you know what? No one said that Vivek said this. I think graphs are hard. I have seen a lot of students struggling with graphs. I mean, VT graph, displacement time graph, distance time graph, acceleration time graph, speed time graph. All these graphs come together and they start to confuse you, right? Don't worry. Yes, Shivasini will deal with laws of motion in coming sessions. Don't worry. Today it's all about motion. Fine. All right. Don't worry, Shivasini. We'll deal with laws of motion. Today is the day when we talk about motion. Laws of motion deals with what? It deals with forces, right? The effect, or motion is what? Effect of force. We'll deal with force and laws of motion. Today we are going to deal with motion. All right. So let's start. We'll be having 8 questions today. 8 good questions. What I want is, I want you to interact. I want you to try and answer every question. Let's make it a habit, right? Try and answer every question. Please. The worst you can do is not answer, all right? It doesn't matter. It's a right answer, wrong answer. Please try, all right? Come on, let's do it. Equations of motion, all right? Don't worry, article. I heard you. After today's session, I believe a lot of you will have, this fear will get out of you. Don't worry. Come on. Let's take a look at the contents first. Distance and displacement we'll be dealing with, right? Velocity. Okay, velocity is there. Uniform and non-uniform motion. This is how slowly it becomes harder, right? Uniform, non-uniform motion. Acceleration, distance time, and velocity time. Graphs, I know you said graphs. We have questions from graph. We have good questions, all right? Equations of motion. So, nice, all right? Don't worry. Equations of motion. It's there on the screen, right? You can see it. We'll deal with this. Don't you worry about this. Uniform circular motion, all right? So you have just now taken a look at the contents. The topics we'll be dealing with in this session. Let's start with the questions. I hope you are ready with your pen, your notebook, right? Let's start this sprint. Come on, let's do it. The first question is here. What is the question? The question says, the displacement of a moving object in a given interval of time is 0. Guys, whenever you are reading a question, first of all, read it, right? Read it patiently, understand what are the important keywords, and then answer it. Fine, okay? Hi, Vivek. Uniform circular motion. Yes, Papia, we have questions from that. Don't you worry about this. We'll be dealing with this concept. I'll explain you what exactly is uniform circular motion, all right? It's easy. If you get the basics right now, it doesn't matter if it's going in circles or in a straight line. That's okay, all right? Let's get our basics straight today. All right, guys, come on. Hello, Pabali. Come on. Shall we start? Come on, guys, answer. Try and answer this question. This is a very short answer type of question, right? Which means a little subjective. And what I want is, it's okay. You can't type the answer completely here in the chat, but I just want you to give me the crux, right? Come on, you can do this. Screen isn't visible, Shivasni says. Shivasni, I think this might be a net issue. Try and refresh once, and because I think it's fine for rest of us, right? Okay. Hello, Gaurav. Come on, guys, come on. Let's do this question. The displacement of a moving object in a given interval time is 0. What is 0? Displacement of a moving object. Would the distance traveled by the object also be 0? Justify your answer. If I were to ask this question differently, the question is talking about what? Relation between distance and displacement, right? So, are we clear with this concept? If we are clear, we can answer it. Come on, let's try it. Shainita says distance will not be 0. No. Nice. All right. Keywords. Displacement of a moving object is 0. All right. What is distance and what is displacement? Let's have a very quick recap. Come on. If you are going from here to here, this is what the Google Maps look like. Almost, right? If you are going from here to here, the maps show you what? That length of the path you have to cover, right? So this is what? This is the length of the path covered, which means it is distance. This is what? The shortest distance between the 2 points, the initial point and the final point. This is what? This is the displacement. I can see all of us are giving the correct answer. Nice. Okay, I'll change the question a little more. Can you give me a relation between distance and displacement? A general relation, which is very frequently asked in exams. All right, come on, try this. Distance dash displacement. Try this, come on. Meanwhile, I'm explaining this question to you. So, let's take an example. If this car is going from A to B and returning back to A, what can we say? The distance, watch the animation very closely. Watch this animation. Look at the graph. Distance is constantly increasing, but after this, the displacement, it is decreasing, right? Which means initial and final points are becoming same, all right? Which means what? Displacement is 0 when this body comes back to position A, but distance cannot be 0. It is the length of the path covered, right? So, one more example could be a body going in circle. Papaya, listen to me. Circular motion, we are getting into a hang of it slowly, right? Distance is scalar, vector is displacement. Unit of displacement, distance is never lesser than displacement. Devarajan, very good. right. Displacement can be 0. You are right. Very good. Nice. Nice, yeah. So, the relation you are telling me is, if I tell you distance and displacement, distance will always be more or equal to displacement. Distance can never be less than displacement. Is this concept clear to you? Right? Nice, Ashish. Very good. All right. So, we got the answer, right? Yes, the answer is, how will you write it? You will write it nicely. You will write the explanation, you will give an example and give this relation. Distance is greater than or equal to displacement. Simple. You won't write stories in very short answer type. You don't want to waste time, right? Okay. Very good. Very good. It's okay, Deepak, if you said wrong. I told you, whatever mistakes you want to make, please make them here and now. Don't make them in exams, right? Come on, let's do it. Nazish. Yes, I've taken your name. Give me correct answers and yes, your name will be taken. Don't you worry about this. Oh, I did not even started with the question and you gave me the answer. Aman, Parvati, Vidushi, Shivan. Oh, nice. A, Anushka, Sunil, Parvati. Very good. So, the question is, which of the following figures represent uniform motion of a moving object correctly? Okay, I can see all of you are telling me A. Nice. I'm not saying it's the correct answer or not, but very good. The attempt is good. Let's communicate now. Moving object correctly. What? Uniform motion. When do we say a body is in uniform motion? Uniform speed or uniform velocity? Come on, think. Yes, yes, yes. All of us are telling A. Nice. So, what do you think? Uniform motion means what? Uniform speed or uniform velocity? Think, come on, think. It's a very important concept, I'm telling you. A lot of questions will deal with this. Uniform motion. This is uniform motion. And you are saying uniform speed. Equal distance and equal intervals of time. That is correct. That is uniform motion. That is uniform speed. And you know what? Uniform motion means constant speed or velocity. Both are uniform motion, alright? So don't you worry about this. Which one? Both are said to be uniform motion. It depends on what context you are building up. In this question, if you had taken a look at the options, all the options were of displacement, distance time graph, which means you have an option of speed only. And that's why we are talking about uniform speed. So if I am also in same direction, nice Papia, which means it is velocity now, right? So, if I were to change this question, I could also ask you, out of these 4 options, which one is uniform speed? It is more direct, but uniform motion, it's an indirect question, right? Yes. Yes, Hema, you are correct. Very good. Nice, Shanita. Nice, nice. Very good, very good. We have very good students over here. Nice. All right. So, distance time graph. What do you see? You see a straight line. You see a straight inclined line, right? What does it mean? It means it's a uniform speed. The slope of the line is constant. What is the slope? Delta or change in distance. This delta means it's change. It's okay if you don't know it. It is delta D means change in distance. This is what? Change in time. If I write delta D upon delta T, this is what? Speed, and it is constant. Why? The line is straight, it is inclined, it is uniform speed, right? A, nice. So, slope of distance time graph gives you what? Speed. Only concept we are supposed to use over here is this. Fine. Now, rest of the graph, what are they telling you? Body at rest. This graph, where distance time graph is a straight line but parallel to x-axis. It is what? It is the body is at rest, right? Right? The body is at rest. Why? Distance is constant. It is sitting at its place nicely, which means the body is at rest. So, this is at rest. Alright. Thank you, Hema. Alright. Okay. Uniform motion. We have discussed about this. Non-uniform motion. Again, one more level of complexity. Non-uniform motion. Look at these 2 graphs. I know the question is not asking you this. Can someone tell me? This is the first graph, this is the second graph. Which one of them is a accelerated motion? Come on. Nice, Subhas. Yes, angle is 0. Angle is 0 when it is parallel to x-axis. You are correct. What does the option B tell? This is my question to you first. Don't worry, I'll tell you, but I'm asking this to you first. Does not cover equal distance, equal to time. All right. Yes. Nice. Yes. That is what? Non-uniform. Both are non-uniform. That's true. Which one of them is accelerated and which one of them is retarded? The first one or the second one? Come on, think. Nice. First graph is accelerated motion. You're right over there, Papia. Article, you are also right. Ashish, very good. Harini, very nice. Nice, nice. I really love doing this with you guys. Very good. So, first one is accelerated. Why is it accelerated? You can see the graph is curving up, which means more and more distance is being covered in equal intervals of time. And there is a nice way of doing it. If you make lines like this, one line, two line, third line, the slope is increasing, right? Which means speed is increasing. It's an accelerated motion. Second one is retarded. Look at the lines, one line, two line, three line, four line. The lines are getting parallel to x-axis slowly, which means speed is decreasing. It is a retarded motion, right? Nice, Subhas. Very good. So, the correct answer is A. And I hope you got the answer of your question. What does option B represent? It represents non-uniform motion. More precise is accelerated motion, right? Calculus, obviously you can find, Subhas, but I would say hold on for 2 more grades. Yeah, you will get calculus. You will get a lot of calculus in class 11th. Till 10th, it's still, they'll take it moderate, all right? Nice, Aman. Derivations, yes, we will deal with derivations. Don't worry, right? In long answer types, we'll deal with derivations, okay? First of all, tell me, this question is clear to you? Why option A? Fine. Yes, Hema, don't worry, don't worry. Which derivation you want to? Nirupma, don't worry, class 8th will start soon. As we started with class 9th, similarly we'll start with class 8th also. Don't worry about this. What is calculus? Don't worry. Differentiation, integration, all these things will come in future. Don't you worry about this right now. We are in class 9th. We want to stick to our syllabus and we have the next question in front of us, right? Come on. Yes, yes. Nice. No, sorry, Vidushi, I don't know. All right. It's okay if you couldn't vote. Physics is my favorite too. All right, guys, come on. Next question. Question number 3. 4 cars A, B, C, and D. Come on. We have to speed up. 4 cars A, B, C, and D are moving on a leveled road. Their distance versus time graph are shown in the figure. Choose the correct statement. All right. 4 options are given to you, and I can see a lot of us are giving option B. Option A is also coming. Fahim says A. Sunil, Adrish, Ashish, B, nice, okay. Aman, acceleration means rate of change of speed. You are not wrong over there. To be more precise, it is the rate of change of velocity. Fine, okay. See, I know why you are getting confused. Speed, velocity, I'll tell you this. Why? So don't worry about this. First of all, so we are getting a lot of B's over here. Okay. What is the question asking you? 4 options are given to you and it is saying which one is faster, which one is slower. So you have to take a look at the graph and understand which body is going faster and which body is going slower. How to know this? If you take a look, watch. There is one very basic difference in all these 4 bodies or 4 cars, A, B, C, and D. Their slope, right? And why we are talking about slope? We have to talk about faster or slower, right? So faster or slower means yes, distance versus time. The slope will give you speed. That's also correct. Which of these lines has the highest slope? The question is changed now. I'm asking something else to you. Which one of them has the highest slope? What is slope? Slope is change in distance upon change in time. Change in distance means this. Let's say this is delta d. Change in time, let's say this is delta t. So delta d by delta t, right? This is speed and this is the slope, right? Which one of them highest? Nice. C has the highest slope, means C has the highest speed, right? And how do you determine this? You know what? There are two ways of doing it. This is speed, all right? There are two ways. One is related to the grade, the level that you are in. Means one way is, if I take a line, let's say like this. This line shows me the time is constant, let's say t, fine. This line is cutting all these four graphs at different point, agreed, right? It is cutting B here, A here, D here and C over here, which means d upon t is going to be speed. If d is more in that particular time interval t, if the distance covered is more, means speed is going to be more, right? So if we take a look, for B it is this much, for A it is this much, for D it is this much, and for C it is this much. Means C is covering more distance in that given time interval t. C has more speed, right? That's why slope of C is the highest. You are correct. Yes, you are correct over there. Nice, Vivek. Yes, yes, yes. Maths is the language of physics. You are right. Physics is the thought. Maths is the language. Very good. Yes. Now, this is one way. And second way is something which, I don't know if you understand this, but this is an MCQ. So you don't have to talk a lot into these things. You can just very quickly say, how? Look at the slope. One way is, one line is inclined like this, second one like this, third one like this. The line which is inclined more has more slope, right? This angle for C is highest, A and B. For B the angle is smallest, means slope for B is smallest, right? More inclination, more is the slope. Fine, okay. Yes, by H.C. Verma sir, you are correct. All right. What is delta? Delta means Hema, change. It's a general notation. It means change in distance, right? Distance means this final value minus initial value. Fine, okay. So that's why option B is the correct answer. Triangle means change. Triangle means we say delta, right? It's a Greek letter. Yes. Thank you, Kevin. So Hema, I hope you got the answer, right? Delta means change. Delta D means change in distance. All right. Okay. So option B is the correct answer. We are all on the same page. Means we can move forward. The next question, guys, come on. And let me just tell you, you are doing brilliant, right? You are giving me very good answers, correct answers, and nice. Which means, yeah, we are on the right track. Come on. Come on, come on, come on. Next question. A girl walks along a straight path to drop a letter in the letterbox and comes back to her initial position. Reading this much statement should ring a bell. She went to do something, to drop a letter into a letterbox and came back. Okay. Initial position and final position are same, right? Right? Nice. Nice, Aman. Easy peasy, right? Her displacement time graph is shown in figure. Plot a velocity time graph for the same. I told you, graphs, I agree, a little complicated, but with more practice, graphs are the easiest and the quickest answer you can give for any question. Come on, let's try this question. You know how you will answer it to me? All right, displacement is 0. You are correct, Hema. Right, right, right. I mean, yeah, Vidushi, I mean, we have a lot of teachers, so it's okay if we don't know either very well, but still, don't worry. Right now, let's focus on the question, guys. Come on. What is the answer? And how will you answer it to me? You can tell me the velocity, right? The velocity in the two intervals. You can answer it like this. Displacement is 0. We have to plot. Yes, yes, yes. Okay, okay. All right. Velocity time graph, right, right, okay, okay, nice, Adrish, you are right. Yes, yes. See, average velocity is 0. If I take the total 100 seconds, velocity is 0 because displacement is 0. But while you are making the velocity time graph, you have to take intervals. Which two intervals? Tell me, come on. Slope of displacement time graph of an object gives you the velocity, right? So think in terms of slope of this graph in two intervals. Yes, Subhash, you are right. It is maximum in 50 seconds. And these are the two intervals, 0 to 50 and 50 to 100. Think in the term. And why am I saying this is an interval? Look at the graph now. Here, the slope is positive, right? Because the line is like this. Here, the slope will be negative because the line is like this, right? That's why these two intervals take notice. Yes, Shanita, you are right. 2 is there. Yes. Yes, Subhas, you are right. At the starting point, ending point. Correct. Nice. So, how should we do it? Come on. We have to make velocity time graph. Let's talk about the slope. I told you there are two intervals. Why two intervals? Because at 50, it is changing. That's why I have broken down it as one interval. Here, the slope is how much? Change in displacement, right? Change in displacement is how much? 100 is the final one. 100 minus 0 upon change in time. Time is how much? 50 minus 0. This is what? 2 meter per second. Ramesh, yes, very soon. I told this to you. We have started class 9th. We'll start with class 8th also. Don't worry, guys. Come on. We have started this channel as 8th, 9th, 10th. We'll be dealing with 8th, 9th, 10th. Don't you worry about this. Have some trust and let's focus. Come on. Nice, Vidushi. 2 and minus 2. Very good, very good. Nice article. Not 20. It's 2. Not 20. Right? Yes. So, we got the slope from 0 to 50 as 2 meter per second, which means 50 is the interval, and from 0 to 50 seconds, it is 2 meter per second, which means this is the velocity from 0 to 50 seconds. Fine. Now, think 50 to 100. What will happen? What is the slope? 50 to 100. Again, same formula. What is the formula? Change in displacement upon change in time. Displacement changes how much? Final is 100. Initial is, final is 0. Initial is 100. Means 0 minus 100 upon 100 minus 50. This is what? Minus 100 upon 50. So this is minus 2 meter per second. Minus 2. Right? You were right over there, Vidushi. Yes. Nice. Nice, Subhas. Very good. Yes. Fahim, you were telling about the last question, huh? Yes, yes, yes. Very good. So, this is minus 2. You are right. So, this is how the velocity time graph will look to us, right? And tell me, are graphs difficult? Not really. If you have the concept straight, the graphs are easy, right? Yes, Hema, you are right. U minus V by T, it came from what? V equals U plus AT, right? So, V minus U upon T. It is acceleration, right? Right? Okay. It's all right, article. Don't worry, don't worry. Wrong answers are actually good, if I tell you. Once you have made a mistake in one question, means you are never going to repeat it again. All right? Okay? Very good, guys. Very good. Nice. All right. Come on. So, let's move towards the next question. Lot of graphs are coming towards our way. All right? Come on. Let's focus. Thank you, Aman. Even I love physics. Oh, your favorite part is graph, huh, Vidushi? Nice. Graphs are good. I really like them. All right. Come on. 10th, you'll see me. Don't worry. Come on, guys. Next question. The velocity time graph shows the motion of a cyclist. What do we have to find? We have to find its acceleration. Okay. Its velocity. All right. The distance covered by the cyclist in 15 seconds. It's an easy question. I'm telling you, it's an easy question. You just have to notice the graph properly. What is the graph given to you? It's a velocity time graph and a straight line parallel to x-axis, and as I think, yes, nice Subhas, acceleration is 0. And how did you know that? Because slope of velocity time graph gives the acceleration. When a line is parallel to x-axis, what is the change in velocity? Come on, what is slope? Slope is what? Change in velocity upon change in time. What is change in velocity? If you take final velocity over here, initial velocity is here. So final is also 20. Initial is also 20 meter per second. Change in velocity is 0. Means it is what? The slope is 0. Means acceleration is 0. Right? Yes. Very good. Uniform motion. Very good. Yes, Rishu. Nice. Thank you. Thank you, article. No, Papaya. It is not at rest. It is moving with a constant speed. Sorry, constant velocity. It's a VT graph. That's why. Constant velocity. Alright. Velocity equals 20 meter per second. You have already given the answer. I can see. Oh, nice. Chota beam. Alright. 0, 20. Alright. Okay. Okay. Nice. Nice. So, you can see velocity is constant at 20 meter per second. Acceleration is 0. That's why it is constant. Fine. So, velocity is what? It is 20 meter per second. Right? So, second part is also fine. The third part, distance covered by the cyclist in 15 seconds. All right. Yes, 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 we are getting the distance. Now, I want to ask you something again. The question has given you VT graph. It is asking you distance. Sir, shouldn't distance be asked from a speed time graph? How is the question asking distance from a VT graph? Right? This can come in our mind, right? It can. So, all right. Here I want to break that confusion. First of all, speed, velocity. We always tend to think they are different. They are different, but if a body is moving in a straight line, right, in a straight line, in one particular direction, speed and velocity become same. Why? Direction is constant. Now only magnitude is left, which means speed is equal to velocity. So that's why. Whenever this kind of a question is asked, it means the body was traveling in one particular direction, right? Okay. So that's why Vt and speed time can be same only if the body is traveling in one particular direction. Fine. In a straight line. Right. Suvarna, thank you. Alright, so we have to find distance. How to find distance? Area under the VT graph. That is distance. Fine. So how to find a distance? At 15, right? So this is the line and we have to find this area. This looks like a rectangle. How to find area per rectangle? It is length multiplied by breadth. So you can do 20 multiplied by 15. So that is what? 20 multiplied by 15. What do you get? So you are right over there. 300 meter. Yes, Chitra. Nice, nice, Shanita, Chitra, Vidushi, very good. Adrish, thank you. Devrajan, nice. Distance equals velocity into time. You are right. Very good. So we are done with this question, right? I told you it was an easy question. Come on. This question is good. Yes, it's a moderate level question. This meter over here shows you the difficulty level. It's a moderate level question. Yellow is moderate. Fine. Very good. Should I call you Chota Beam only? I mean, but yeah, your answer is correct. Yes. Right, right. Very good. Thank you, Shanita. All right, guys, come on. Next question. This is a good question. It's a prove something question, which means what you can do is, I understand that you can't tell me the answer, right? But what you can do is, you can tell me at least with a smiley or a thumbs up or with done that you have proven this. Fine. All right. Okay. So is the deal clear? I'll keep explaining and you can just tell me, are you done with this question? Is it fine for you? All right. Thank you, Chitra. All right, guys, come on. Two stones are thrown vertically upwards simultaneously with their initial velocities u1 and u2. Fine. Where? Thrown up. right? Okay. Prove that the heights reached by them would be in the ratio of u1 square is to u2 square. But the question is also giving you one very important information, that is, assume upward acceleration is minus g and downward acceleration is plus g. It's very important. Yes, I'll tell you why. Nice, done. Very good. Nice, nice. Very good, yeah. So, let's visualize the problem first. Two stones thrown up with initial velocity u1 and u2. Then what will happen? If let's say u2 was more, it will reach more height. It's my assumption. Don't you worry about this. All right. Height of first one is let's say h1. Height of second one is let's say h2. This is all assumption we have to make to answer this question, right? So this is something which we have visualized. Now what we have to prove, h1 is to h2 is u1 square is to u2 square. All right, fine. All right, okay. So what to do now? Come on. When you have thrown something up, when do you think one interval will come? What interval? When you throw something up, it goes up, 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 slows down, and then falls back. So this point where the final velocity becomes 0, that will give you the height, right? So we are saying v1 equals 0 and below is g, because the question told you this. Question told you assume upward acceleration is minus g and downward is plus g. Fine. All right. Okay, Mukesh, don't worry. By the end of this session, ask this question to me again. I'll tell you. Don't worry. Tomorrow is your exam. I won't disappoint you. I'll tell this to you. Okay. Yes. All right. So u1 square is to u2 square. Second, v2 equals 0. Fine. These two cases are fine. All right. Now, what to do? Let's analyze. You have to deal with the ratio of h1 is to h2. Means what? Which equation do you want to use? Come on. V is 0. Can't you use v square equals u square plus 2as? Why? Because v, you know, it is 0. U is given to you. A is given to you. H is something you need to find. That's why this equation will be most helpful to us, right? So, come on. Let's use it. For the first stone, v is 0 equals u1 square plus 2, right? And what is the acceleration in the upward direction? It is minus g, right? It is minus g. Understand? The question told you this. Multiplied by h1. So u1 square equals what? 2g h1. I just took it to the other side. Simple. Nothing else. So h1 is how much? u1 square upon 2g. Similarly, you will also get u2. Sorry, h2. h2 will be how much? u2 square upon 2g. Now, if you find h1 is to h2, what do you get? 2g and 2g will cancel out. u1 square is to u2 square. And this is something which you want to prove. You have proven this, right? Thank you, Hema. Nice. All right. Hey, computer, come on. Don't spam this, man. Yes, by third equation of motion. All right, guys. This was a long answer type question. Now, one problem which I have seen a lot of students face is they don't know how much to write in the explanation. So what will you do? I'll tell you how much to write. What is a good and precise answer? First of all, you will tell what equation you want to use, right? Then you will tell, using third equation of motion for the first time, you will find h1, you will find h2, and then you will write h1 upon h2 equals u1 square upon u2 square. This much is enough. No need to write more, no need to write less. This is a good answer. It will give you complete and full marks, all right? Don't you worry about this. Fine. All right. Okay. And you know what? When I was small, so whenever these questions we used to do, I had a habit of writing hence proved. I don't know if you have it or not. It felt confidence, right? So hence proved. Fine. Okay. All right, guys, come on. Next question. This is a difficult question. This is question number 7. I want everyone to try this sincerely. Come on. Thank you, Adrish. Yes. Thank you, Hema. Come on, guys. Come on, come on. Next question. What do you think? A car starts from rest and moves along the x-axis with constant acceleration 5 meters per second square for 8 seconds. All right. If it then continues with constant velocity, what distance will the car cover in 12 seconds since it started from the rest? Question looks big. It seems there is a lot of information. So read the question slowly, part by part, right? Nice. 39 out of 40, huh? Very good. For class 9th, you have Hema, for class 9th, no, you have a mixture. It's not only MCQs. It's not only objective, right? There are different types. That is for class 10th. Hi, Kriti. All right. Okay, okay. Are we able to solve this question? Come on, think. Visualize it. Read it slowly. Break the question. Car starts from rest means what? U is 0. Fine. Means U is 0. All right. Moves along the x-axis with constant acceleration. It is going in one direction with constant acceleration of 5 meters per second square for 8 seconds. Then what happens? It continues with constant velocity. Means very important information is given to you. After 8 seconds, the acceleration stopped. Whatever velocity it has attained, it is now moving with a constant velocity. Fine. Is this much information clear to you? If this is clear to you, this question is easy now. All right. Oh, okay. Subhas is giving the answer. Papi also giving the answer. Nice, nice. Thank you, Mukesh. All right. Okay. So let's start with the information given to us. Let's visualize the problem. First of all, what is given to us? There is a car, right? A car starts with from rest, means U is 0, and it accelerates till 8 seconds. Let's say this is point B. Fine. Let's say this is point B. You have to find what? You have to find total distance covered, right? Distance or displacement doesn't matter. Why? It's a straight line. That's why. Okay. So how to find a distance? U is given to you, right? Time is given to you. Or you have to find displacement. All right. What else is given to you? Think. Acceleration is also given to you. Means which equation? Come on. It's okay, Mukesh. Don't worry. We are here, right? It doesn't matter where you see me. What matters is what we are dealing with. It's important to solve questions, and it doesn't matter. Platforms could be many, but what matters is what you are learning. Everyone is trying really hard to make you understand things. All right, Mukesh? Don't worry. Wherever you see me, every teacher is trying the same thing. All right? Come on. So, which equation? Come on, which equation? Question is, Rushil, you missed the question, huh? Yes, second. Very good, Vidushi. The equation would be S equals ut plus half at square. Why are we using this? Because we know all these variables are given to you. So S will be how much? Come on. U is 0. This will be 0. Half at square. Half of A is how much? 5 multiplied by t square means 8 square. What will you get? You will get 160 meters. Very good, Shivani. Nice. 160 meters. Yes, Subhas, you are right. You are one step further. Second and third. Nice. Okay, okay. Yes. So, you got the S. But you know what? You need one more thing. To proceed further, you also need, this is 160 something you found, but after B, the car is not accelerating. It is moving with constant velocity. How much velocity? Whatever velocity it has attained till this point B. How to find that? Which equation? See, you can use third equation also, but personally I would say it's easy to use the first equation. Why? Because V is something you need to find. U is 0 given to you. A is given to you and T is given to you, right? So can't you find this? A is 5 multiplied by T is 8. So this is what? 40 meter per second. Yes, you were right. This was 40. So we got the velocity at point B as, yes, Abhijit, 40 meter per second. Now, after B, the car is moving with a constant velocity of 40 meters per second. How much time? For how much time? For 4 seconds. Because till 12 seconds, right? 167. I think this was a typing error. 240. Adrish. There might be some problem. Vidushi, you are right. It is 40 meters per second. Nice. Okay. So, we got VB as 40 meters per second. Now it is moving with a constant velocity. You have to find displacement or distance because it's a straight line motion. How will you find it? Do you want to use an equation? Yes, you can. You can use the second equation again. From B to C, constant velocity. You can use the second equation again. No problem with this. But do you really want to use it? Why? If acceleration is 0, velocity is constant, time is given to you, the displacement will be what? Velocity multiplied by time, right? It will be 40 multiplied by 4. So this is 160 meters again. So total distance would be how much? S1 plus S2. 160 plus 160. That is what? 320. So yes, 160 for second part. So Hema, you are asking for derivation. Which derivation? Derivation for equation of motion. Really? Okay, I'll give you a hint and you can try it forward. Whenever you are trying to derive something, all the equations of motion, they are valid only for constant acceleration, right? Constant acceleration. So take a graph, right? Take a displacement time graph and use all the properties of the graph. You will get everything. Don't worry. Fine. Third equation of graphical method. See, if you know the first equation, that is V equals U plus AT, and if you know S equals UT plus half AT square, and you have to find the third equation. What can you do is, third equation is what? V square equals U square plus 2AS. You just have to remove T from here. Take the value of T from the first equation, put in the second equation, and you will get the third equation. Don't worry about this. It's very simple, right? And from graphical method, if you are saying, it's the similar kind of thing you can do. All right. Okay, guys, come on. Again, I'll show you how to write a proper answer for this. For A to B, first of all, you will calculate everything. You will write the S1 is 160 meters. At B, you will tell VB is 40 meters per second. And do you see a pattern? You write, first of all, the formula, the equation. You put the values, you get the answer, and then you write it. Fine. Next, you will write the B to C part, and here you will again get the answer, right? Get the answer and then write it properly. S1 plus S2 is 320 meters. This is how you write a proper solution for the exams, right? Because you will get marks for steps also. All right? Okay. Yes, Hema. Graphical method, it's also simple. Don't worry. If you make a graph like this, no. If you make a graph like this, what can you do is, you will first of all find the first equation of motion, right? Second also, and then you can do the same kind of thing, right? Don't you worry about this. All right. Thank you, Nati. I'm lucky too if you are in this session. All right, guys, come on. Last question, and I want correct answer for this question. Now I understand we are all very comfortable with all the questions of motion, right? So let's come on, let's do this. And this question is for, I think Hema asked or Papi asked, uniform circular motion. I don't know. So this is for you, circular motion, right? Come on. Hey Shagun, thank you for joining today. Yes. Oh, nice, nice. You guys are giving the answers also. C, there is one B also. Adrish, it's okay, it's okay. Doesn't matter. Whatever you think is the correct answer, just give it to me. I'm here to explain it to you. Don't worry. Suppose a boy is enjoying a ride on a merry-go-round which is moving with a constant speed of 10 meters per second. It implies that the boy is a merry-go-round. What is a merry-go-round? We all like to go in merry-go-rounds, right? I mean, I was personally scared of going to merry-go-rounds, but still. merry-go-round, it goes into circles, right? It goes in circles, which means with a constant speed of 10 meter per second. All right, a lot of us are saying accelerated motion. Yes, you asked this question, correct. All right, so it is moving in uniform motion. I can say it is in uniform motion. Why? Its speed is constant. All right, all right. So that's why I'm saying uniform circular motion. All right, because speed is constant. Do you think velocity is also constant? Yes, Kamalendu, it is circular motion. To be more precise, it is uniform circular motion because speed is constant, right? Yes, very good, Abhijit. Velocity is constantly changing. Nice, nice. All right. Yes, if velocity is constant, acceleration is 0. But velocity is changing. It is changing constantly. Why? Because velocity has two important concepts. Magnitude, which is constant. Why? It is 10 meter per second. Constant speed means velocity's magnitude is constant. Is the direction constant? It is not. Why? It is going in circles. Direction is changing continuously, right? Okay, okay. If direction of velocity is changing, means I can say velocity is changing. If velocity is changing, acceleration is going to be there. Why? Because acceleration is rate of change of velocity. Very good, Vidushi. Yes. Can someone tell me the direction of acceleration? I know this is above your grade a little bit, but still I'm asking this to you. So you have reached the correct answer. It is accelerated motion. Can someone tell me what is the direction of acceleration? Nice, Kamalendu. Yes, yes, yes. Kevin, good, good. Oh, yes. No, not tangent. Kamalendu gave a correct answer over there. Yes, yes, yes. All right. See, I won't explain this to you the direction properly, but still, I'll give you a hint. It's going to come in the next class. Don't worry about this. Uniform circular motion. Velocity is changing. Why? Because look at this. Velocity is a vector. It has magnitude and direction. And if it is changing its direction constantly, means velocity is changing, means there is going to be acceleration. In which direction? Direction would be towards the center. And yes, yes, Suvarna, you are also right, towards the center. Nice. Vidushi, direction of velocity is towards the tangent, not acceleration. Okay. Direction of velocity is tangent to the circle. Acceleration is towards the center. We call it centripetal. Don't worry if you don't know this. It's not in your syllabus right now. I'm just telling you something extra. It's okay. Right? Okay. So that's why correct answer is option C, in accelerated motion. Now, with this question, I can very surely tell you that we've got you covered. Don't worry about this. Class 9th, we are here. We are going to stay here and we'll keep having these sessions. So that's why we have got you covered. I just want you to practice more questions. I just gave you some very good questions, but I want you to practice more questions. All right, come on. Nice. Centripetal. Force is acting on center. You are right, Hema. Nice. Cutie, baby. Yes, you gave the answer first. Thank you. All right, all right. Yeah, Shagun. 5 baje, yes. 9th class, 5 p.m. All right. So, for next session, I'm going to give you what is the next session, all right? Master force and laws of motion. So, a lot of you told me, right, laws of motion, you feel difficult. Next session is about that. So, how to effectively take advantage of this session? Come prepared, revise, and then come to the session, and you know what, we'll solve together, right? We can have this exercise together. Thank you, Vidushi. All right. Lesson explaining, Kevin. You know, it will take a lot of time if we do this here. So that's why what I'm saying is, you revise. Every question deals with some concepts, and I'm here to explain all of them to you very clearly. So I want you to prepare and practice with me, right? So prepare yourself and practice the questions with me. Thank you, Abby. And guys, there's one more free trial class. In the description you have all the information. Try it. I mean, it's free, so you can try it. All right, don't worry. And if you like it, well and good. If you don't like it, it's fine. All right. My name is Saurabh. Thank you, Devrajan. And thank you, Shagun. Someone was asking me refraction. See, this is apart from this session, but yeah, someone was telling me that you have an exam tomorrow about refraction. So what is refraction? Refraction is the thing, it's the bending of light. When light travels from one medium to another, transparent medium of different refractive index or different optical density, it bends. That is refraction, right? I just gave you your answer, right? Okay. All right, guys. It was lovely having you today, and I'll be seeing you again in the next session. Till then, I would say bye-bye, take care, and practice. All right? Okay, I'm Saurabh signing off. I'll see you.